what is the sum of the roots and what is the product of the roots. And if time permits, then we'll go for the next topic, that is nature of the roots also. Fine. So to find the roots of a quadratic equation, what we do is, we know that the standard form of a quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0 and a comma b comma c belongs to complex numbers. We have discussed yesterday clearly about it. Fine. Okay. Now we want to find roots of this quadratic equation. That is nothing but x value. So it is also known as solution. The value of which, or the values of x for which this given equation or this quadratic equation satisfies. Means if you substitute that x values, you have to get 0. You have to get 0. That is called satisfying. Okay. So those type of x values are called as roots or solutions. Those type of x values are called as roots or solutions. And basically remember, only for two values of x, it satisfies, not for other values. You can substitute any number of x values, no problem. But it satisfies only for two values. Okay. And those two values are known as roots, or also known as solutions, and they are denoted by alpha and beta. Fine. And today we are going to see how to find that alpha and beta values by using a method called completing square method. So if anybody asks you by which method we find, so better we go for completing square method. So either we convert this given quadratic equation into the form of either a plus b whole square or a minus b whole square, but preferably we use a plus b whole square content or expansion. Okay, fine. Now, so let us see, children, once again. So divide this equation by a. Divide by a. So ax square by a plus bx by a plus c by a equal to 0. So the first step is divide the entire equation by a. Then here a get cancelled. So we get x square plus b by ax plus c by a equal to 0 after dividing by a. Fine. So we have already decided we need to convert this equation into this form. So which is a plus b whole square form. Okay. So that I'll do it on the right hand side. Please observe carefully. We know that a plus b whole square is a square plus 2ab plus b square. Means if this equation, whatever the equation we got at the end, last stage, if we write in this form, then we can convert into, or we can write it into a plus b whole square. So to understand that very clearly, let me write that a square plus 2ab plus b square here only. So once again, I'm repeating, we want to convert this entire step, x square plus b by ax plus c by a equal to 0 into this form completely. Then only we can write which is equal to, sorry, I wrote equal to 0, not equal to 0. So then only we can write which is equal to a plus b whole square. So to convert into that a square plus 2ab plus b square, you need to understand what is a value, what is b value. Then only we can convert into a plus b whole square. Fine. So for that, do comparison. So please observe the comparison, everyone. So the first term is x square, and in the expansion, the first term is a square. So let us compare that. Our first term is x square, and in the expansion, the first term is a square. So square get cancelled. So we'll get x equal to a. Means indirectly a equal to x. Indirectly a equal to x. So we got a value. 1 second, children. So we got a value. Now let us compare the second term. So in our expansion or in the equation, okay, in the last step, the second term is b by a times x. But in the expansion, the second term is 2ab. Already a value x, substitute here. Okay, so b by a times x equal to 2 into a value is x into b. X get cancelled. Now, we want to find this b value. According to our expansion, a plus b whole square, we already found a. Now we want to find b. So send or transpose 2 to left side. So what we get? B by 2a equal to b. So in the expansion, we will have b. So that b value is b by 2a. Hope you understood how to find a value and how to find b value. Fine. Fine. So we have a square, we have 2ab. But we don't have b square. See, b square means what? Whatever the b value we got, if you square it, then it must be what, children? It must be b square by 4a square. But this term is not there in the last step. Is it there? No, it's not there. So we will provide from our end. We will add from our end. Okay, fine. So now see, observe carefully. This last step, once again, rewrite it as x square plus b by ax. So a square plus 2ab over. A square plus 2ab over. Plus b square we need. B square is how much? Which is b square by 4a square, which is added extra, like separately. So we will subtract the same thing again. Plus c by a is as it is equal to 0. So hope you all understood this step. Okay. Now, from the first term, yeah.
Once can you explain again?
So now everything I'll erase. Now I will follow the same step, Amma Soumya. The first term is x square. A square is over. Second term is b by a x, which is 2ab. Soumya, tell me a square plus 2ab. After that, what we must get, Soumya? Soumya, respond. A square over plus 2ab over. I have just copied the same term here.
B square.
That b square we have already marked here. That is not there in the step, in our step. That we will write here. B square by 4a square. So you can ask me, sir, which is not there in the step, in the last step, or in our step, how can you write? Yes, no problem, you can write. But to balance it, again, you have to subtract it. Subtract the same term. Then again, please observe carefully. This term will get cancelled. Then there will be no change in the previous term, like that. If you want to understand this scenario still better, please observe carefully. Forget about this step. Let me go to the some like best example. Suppose I have x plus 3 equal to 5. This equation. Please observe carefully. Everyone, those who not follow the scenario. X plus 3 equal to 5. I have wantedly added some 4 on the right hand side. Okay. If you want still better, still in a better way, please observe carefully. 3 plus 4 equal to 5 plus 2. Children, can someone please tell me, is this correct statement or wrong statement? 3 plus 4 equal to 5 plus 2. Is this correct or wrong?
Correct.
3 plus 4 is 7 and 5 plus 2 is 7. Now, on the left hand side, 3 plus 4 plus I'm adding 8 equal to 5 plus 2. Is this correct now? Is this correct?
No, sir.
So, there itself I have to even subtract. Then only the equation will be balanced. Means there will be no change in the previous equation or the entire value. So, whatever we add, at the same time, we have to subtract the same quantity, the same amount. We have to subtract. That is what I did here. That is what I did here. See, once again, I'll erase this line, this line. So we need b square. We need b square. A square we got plus 2ab we got. We need b square. So that b square means indirectly b square by 4a square. I have added. So for balancing, again I have subtracted the same thing. Is that okay, Soumya?
Yes, sir.
Now plus c by a. Plus c by a, I am writing as is equal to 0. Fine. So now everything I'll erase to avoid the confusions. 1 second, children. Just 1 second. Fine. Okay. Now, from the first term to third term, it is clearly in the form of a square plus 2ab plus b square. We all know a square plus 2ab plus b square is a plus b whole square. A plus b. B how much? On the other hand side, we have shaded with yellow color, which is b by 2. Very good. Whole square. Okay. Then what about the next two terms? 1 second, children. Yeah. What about these two terms? Better we transpose it to right side. Better we transpose it to right side. So minus b square by 4a square. So after sending it to right side, it becomes plus b square by 4a square. And we have plus c by a. After transposing into right side, it becomes minus c by a. Hope you all understood. Fine. So now let's move to the next step. So in order to avoid the confusion, I'm erasing everything. Anyway, you understood all these steps. Fine. Now let us simplify the right hand side clearly. So we all know 4a square and a. So definitely the LCM will be 4a square. 4a square and 4a square. If you divide, you'll get 1. So 1 into b square, b square. Hope you know how to take LCM and all. Then if you divide and a and 4a square, you'll get 4a into c is 4ac. So after simplifying, we'll get b square minus 4ac by 4a square. This is the right hand side. And anyway, on the left hand side, we have x plus b by 2a whole square. Fine. Our target is what? Finding x value. Finding x value, though those x values only called as roots or solutions are also denoted by alpha and beta. Okay, so we are finding roots of a quadratic equation. They are also called as solutions of a quadratic equations, and they are denoted by alpha comma beta. Okay, clarity. So what we do is now send square to opposite side. So we'll get x plus b by 2a equal to, we all know, if you transpose square to opposite side, it becomes square root. So square root of b square minus 4ac whole divided by 4a square. For the numerator, if you apply root also, we cannot do anything. Like it is like a sort, we cannot do anything. But for the denominator, yeah, root of 4 is 2, root of a square is a. So we get square root of b square minus 4ac. Sorry, 1 second. Whole divided by, so denominator, root 4 is 2 and root a square is a. So here we have applied square root. So remember, in quadratic equations, as we have to get two values, two different values. So we all know as of now root 4 means 2 according to CBSE level. But according to, like already we have discussed yesterday, complex numbers. So according to that, we can even take plus or minus 2. You can even take plus or minus 2, like plus 2 whole square is 4, even minus 2 whole square is 4. That why again you will understand clearly in complex roots. Fine. So that's why we will apply plus or minus here. So finally, we got x plus b by 2a equal to plus or minus square root of b square minus 4ac whole divided by 2a. Fine. But still, we are not done. We need to find x value. So transpose plus b by 2a right side. So that implies x is equal to plus b by 2a will become minus b by 2a plus or minus square root of b square minus 4ac whole divided by 2a. Fine. Now, when the denominators are same, we can either add the numerators or we can either subtract the numerators. So finally, we get x as minus b plus or minus square root of b square minus 4ac whole divided by 2a. So this is like what generally for a quadratic equation, the roots, if any teacher asks, will say minus b plus or minus square root of b square minus 4ac by 2a. This is how we get the roots. Okay, so we have already discussed it. The roots are denoted by alpha and beta. So you take one root with plus sign, means minus b plus square root of b square minus 4ac whole divided by 2a, one root, and the other root beta is minus b. Minus b will not change. Minus b will not change, only plus or minus. So with plus one root, with minus another root. So minus b minus square root of b square minus 4ac whole divided by 2a. So this is one root and beta is another root. Okay, children. So hope you understood. Did you understand, children, how to get the roots of the quadratic equation? Children?
Yes.
Very good. Very
Yes,
good.
sir.
Now, yeah, very good. Yeah. Okay. So one root is minus b plus square root of b square minus 4ac by 2a. And another root is minus b minus square root of b square minus 4ac by 2a. Fine. Now, let us see how to find sum of the roots and product of the roots. So now we will find sum of the roots. Which is nothing but alpha plus beta. Alpha plus beta. So our alpha value is minus b plus square root of b square minus 4ac whole divided by 2a plus, and beta. Beta is what children? Minus b minus square root of b square minus 4ac whole divided by 2a. Okay, here also again, the denominators are same. So we can just add the numerators. So make as one denominator, then just add the numerators. So the numerators are minus b plus square root of b square minus 4ac plus, again, so plus of, so plus into minus. Children, please observe carefully. Plus into minus is minus. Fine. So this is minus b minus square root of b square minus 4ac. Okay. So if you just observe carefully, this is plus square root of b square minus 4ac, and this is minus square root of b square minus 4ac. So both will get cancelled. Plus square root of b square minus 4ac, and this is minus square root of b square minus 4ac get cancelled. So what else we have? Minus b, which is minus 2b. So minus 2b by 2a. Again, minus, 2 get cancelled. So finally, we will get minus b by a. Okay, so 1 second. So finally, sum of the roots of a quadratic equation is minus b by a. So simply we can write alpha plus beta equal to minus b by a. Fine. Now let us observe the product of roots of a quadratic equation. The second one, product of the roots. Which is alpha into beta. Okay. Now, see children, alpha is minus b plus square root of b square minus 4ac whole divided by 2a. This is alpha value into beta value minus b minus square root of b square minus 4ac whole divided by 2a. So this is beta value. We are just multiplying alpha into beta. You know how to multiply two fractions. Multiply the numerators and multiply the denominators. Fine. When you multiply the numerators, please observe carefully. They are in the form of a plus b into a minus b. If you just treat minus b, here minus b as a, and square root of b square minus 4ac, square root of b square minus 4ac as b. So clearly a plus b into a minus b. They are in the form of a plus b into a minus b. Yes, we all know a plus b into a minus b equal to a square minus b square. So a square, a is minus b square minus b square. So b is what, children? Which is square root of b square minus 4 is, this is b whole square. A square minus b square by 2a into 2a, which is 4a square. Fine. Now let's see the next step. Now minus b whole square is b square minus of, we all know square and root get cancelled, then we'll get minus of b square minus 4ac whole divided by 4a square. Now let us simplify further. B square minus into b square minus b square minus into minus 4ac gives you plus 4ac whole divided by 4a square. So again b square minus 4a, minus b square get cancelled, then we'll get 4ac by 4a square. Again 4 get cancelled, even 1a get cancelled. We will be left with c by a. In the denominator we have a square and 1a will get cancelled, so one more a left. So hence we'll get finally c by a. That is our product of the roots. So hence the product of roots of a quadratic equation alpha into beta is c by a. Okay, children. So we have seen as of now how to find, once again, we'll just have a glance, how to find roots of a quadratic equation by using completing square method. So we found the roots where alpha is minus b plus square root of b square minus 4ac by 2a and beta is minus b minus square root of b square minus 4ac by 2a. Then we have seen how to find sum of the roots, which is minus b by a. And then we have seen how to find product of the roots, which is c by a. Okay, now let's move to the next topic, that is nature of the roots. We have seen what are the roots of the quadratic equation and what is the sum of the roots and what is the product of the roots. Now let us see nature, like what type of roots a quadratic equation will have exactly. That is called nature. Okay, fine. So now let's move to the next topic, children. Nature of the roots. Fine. So indirectly, what type of roots does a quadratic equation will have? That is called nature. Fine. So here we have seen, like in all the solving, we have seen one term which is b square minus 4ac, which is b square minus 4ac. So remember, children, b square minus 4ac is called as discriminant. B square minus 4ac is called as discriminant. Sir, what is this discriminant? Yes, it describes the nature of the roots. So once again, nature of the roots means what type of roots does a quadratic equation can have. That will be described by this term b square minus 4ac. Hence, it is called as discriminant, and it is also denoted by capital D, or in some books you might have seen delta. Both are correct. Either capital D or delta. Nature of the roots are described by the discriminant, which is b square minus 4ac, and it is denoted by D or delta. In some books, you will find the letter D. In some books, you will find the symbol delta. Both are correct. You can go with either of those two. Fine. So now let us discuss one by one. Okay. So once again, please observe carefully. So we know that the standard form of a quadratic equation is ax square plus bx plus c equal to 0. So we will go with two cases clearly. Why? Because those based on those two cases only, your aim one problems were given. So please note it down. And if you don't understand, please ask me again. Fine. So case one, children. Okay. So where a is not equal to 0. Yeah.
Can you show the note?
Which note, Sama?
Before, sir. What you written?
Nature of the roots I have started.
Thank you, sir.
Fine. So now the standard form of a quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0. Now, where a comma b comma c belongs to real numbers. We have already discussed yesterday. Real numbers. Fine. Okay. So real numbers means it can take either natural numbers, it can take either whole numbers, or it can take either rational numbers, irrational numbers, integers, all this. Fine. So now please observe carefully. First one. If d is greater than 0. Already we have discussed what is d. D is nothing but discriminant, which is calculated as b square minus 4ac. If that value is greater than 0, means positive, I can say. If you want, I'll write in the bracket, greater than 0 means positive value. Then the roots are real, means real numbers, and distinct, means they are different. Distinct means different. Suppose if one root is 2 by 3, another root might be 3 by 5 or minus 3, like that. Okay. So request you all, please note down all these points clearly. Based on these points, we have questions in the aim one. Fine. For suppose if d value is 0, whatever the value we find after substituting in the b square minus 4ac term or formula, if we get it as 0, then the roots are real and equal. So what is this? Means if one root is 2, another root is 2. If one root is minus 3 by 5, even another root is also minus 3 by 5. So it will have two same roots, equal roots. Okay, fine. Third condition. For suppose if that value is less than 0, means negative. Okay. After finding b square minus 4ac, if you observe that value is negative, maybe minus 40, suppose, then what type of roots that quadratic equation will have? Then the roots are complex. So already we have discussed yesterday. Complex means what, children? Maybe 2 plus I or 2 minus I, like that. Complex roots. Or better, anyway, we have taken here once again. Better, we have taken real numbers, right? So better you take here imaginary. Or no real roots. Okay. Complex also, no problem. Okay. Means if you get one root has 2 plus I, another root will be 2 minus I. They are also called as conjugate roots or conjugate to each other. I'll write here. They are also called as conjugate to each other. Conjugate to each other. So if one root is 2 plus I, definitely the other root will be 2 minus I. If one root is 3 plus 2I, definitely the another root will be 3 minus 2I. If one root is simply I, the another root will be minus I. Like that. They are called conjugate to each other. Means they will exist in pairs like this. Okay, fine. Now let's move to the next case. What if the coefficients are complex? So before that, better we go with eraser is not working. Fine, no problem. Okay. So now let us observe once again the other condition. Ax square plus bx plus c equal to 0, where a is not equal to 0. See, children, if a, b, c belongs to, this is one more condition, very, very important condition. If a, b, c belongs to q, can someone tell me what is q? Q stands for what?
Rational number.
Very good. Very good, Shasta. Rational numbers. If the coefficients are rational numbers, then what happens? Please observe carefully. So first one, as it is, if d is greater than 0, means discriminant is positive, and it is a perfect square. A perfect square means what? If it is root 36 or root 49 or root 64, root 81, you all know perfect squares. Already we have studied squares and square roots in 8th grade CBSE. Okay, root 4, root 25, root 36, all this. So if that value is a perfect square, then the roots are rational or rational roots and distinct. They are different. So remember always, children, if d is greater than 0, they'll have two different roots. That's why we say distinct roots. And rational roots means what? We have already studied again. What is the rational number? A number which is represented in the form of p by q. Means we'll get fraction type of roots. You can ask me, sir, what is the difference between this and this? Like this here first case and here first case. So here we get numbers, direct numbers, maybe a whole number or an integer or a natural number. But here, if the coefficients are rational, then definitely we get rational roots only. Means 2 by 3, minus 2 by 3, 3 by 5, or 1 by 2, like that. Fine. Let us observe one more condition. If d is greater than 0, means positive, but it is not a perfect square. Suppose say root 35. Is it a perfect square? No, it is not a perfect square. Root 21. No. Root 25 is a perfect square. Root 21, root 24, or root 48, root 63. They're all not perfect squares. So it is not a perfect square. Then the roots are irrational roots. Of course, they are distinct. Anyway, greater than 0, no? So they are distinct. So irrational roots. Again, we have even studied what is irrational. Clearly, which is not a perfect square. Okay, so once we'll discuss here clearly. See, suppose if I write root 25, yes, it is a perfect square, so root exists. Suppose if I write root 24, 24 is not a perfect square. So what is a perfect square? We can write the given number as the product of two similar numbers. Suppose say 25, 5 into 5. Say 16, 4 into 4. Take 9, 3 into 3. Yeah. So 1 minute, just 1 minute. So like that. But here 24, we cannot write as the product of two similar numbers. Hence, it is not a perfect square. Hence, it is a irrational number or also called as a third. Now tell me, Shrestha, ask me your doubt.
Sir, according to our textbook, when it is not a perfect square and delta greater than 0, then the irrational roots and conjugate to each other, no, sir.
Yeah, that is, that again I will explain. No worries. First, irrational roots I'm explaining. Anyway, you see, irrational complex, all the time they will occur in conjugate pair only. So, see children, again, one more here. Already in the case of complex, we have discussed it. Suppose 2 plus I, it is 2 minus I. That is called conjugate pair. So here also, in the case of irrational numbers also, they will occur as a conjugate only. So what is this conjugate? Suppose if it is root 3, then the other root is minus root 3. If it is 1 plus root 3, then the other root is 1 minus root 3. If it is 2 plus root 3, then the other root is 2 minus root 3. So like this, they'll occur in pairs only. That's why they are called conjugate to each other, means conjugate pairs. Is that okay, Shrestha?
Yeah, thank you.
Actually, after explaining irrational roots, I was about to explain that concept. Fine, anyway, no problem. So hope you understood at a time what is irrational and the next continuity, which is conjugate pair. Fine. Next, equal to 0, anyway, you all know. So third one, if it is equal to 0, the same concept again. So roots are equal. Roots are equal. So rational roots. Why? Because we have taken the coefficients are rational. So we get rational roots equal to 0. Then the roots are roots, but they are equal. Rational and equal. So again, same concept. Minus 3 by 5. So another root is also minus 3 by 5. Or 3 by 2. Another root is also 3 by 2. Like that. Okay. Fine. Now fourth one, same condition what we have discussed there here, less than 0. So less than 0 means again here also, yes, the roots are complex. So whenever it is complex, they'll occur in conjugate. Okay. So again, same concept. 1 plus I, 1 minus I, 2 plus I, 2 minus I. Or you take something bigger one, 3 plus 5i. So another root is 3 minus 5i. So like that, in the case of irrationals and in the case of complex numbers, they occur in conjugate pair only. Okay, fine. So this is about nature of the roots. So can someone tell me nature of the roots purely depends upon, we are always writing d greater than 0, d less than 0, d equal to 0. So what is that d meant for?
B square minus 4AC, discriminant.
Discriminant. It is also called as discriminant. So clearly, the nature of the roots are depends upon or described by the discriminant, which is b square minus 4ac, and which is represented as d or delta. Fine. So we have seen the conditions. Now let us work out one or two problems. Then we will continue by tomorrow. Fine. So just observe some problems from aim 1. This is actually all about aim 1 children. So we don't have to like discuss anything else other than this from aim 1. Yeah. So let us solve one or two problems. You also solve parallelly. First one. Okay. So first anyway, we'll go with the easy one. The roots of 35x square plus 13x minus 12 equal to 0. So can someone, this is easy question, so I'm just leaving to you. Can someone solve it and tell me the roots of 35x square plus 13x minus 12 equal to 0? So either you can use prime factorization method or splitting middle term method, or better use direct formula x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. You can use this formula or that formula. whichever the method you feel comfortable, you feel easy, you can use that method. No problem at all. It is not a descriptive, so you can use any method. We need final answer, that's it. Okay, fine. So let us substitute here. Minus b value 13. Hope you all know what is ABC. A is x square coefficient, b is x coefficient, c is constant. So plus or minus square root of b square 13 square minus 4 into a is 35 into c is 12, and of course minus 12. C is minus 12, right? Plus, sorry, divided by 2 into a value 35. So let us simplify further. Minus 13 plus or minus square root of, we all know 13 square is 169, and here see children, minus into minus plus 4 into 35, I think 140, right? So 140 into 12. Okay, fine.
160.
What am I based on?
1680.
1680 divided by 70. Fine. So let us add 1680 plus 169, 9, 14, 8, 1. So 1849. So minus 13 plus or minus square root of 1849 by 70. Can someone tell me square root of 1849?
40, sir.
47, huh?
43.
43. Okay, thank you, Amma. So minus 13 plus or minus 43 by 70. So you can split here to find or to get two different x values. So alpha is minus 13 plus 43 by 70 is one root, and beta is minus 13 minus 43 by 70. So let us simplify further. So okay, so I think this is not going down. I'll do here only. So alpha equal to 30 by 70. So 0, 0 get cancelled, 3 by 7. And beta equal to minus 13 minus 43, which gives you minus 56, right? By 70. Yeah, so let us cancel with 7 table. 7 tens are 70, 7 eights are. So we'll get minus 8 by 10. But still, we can cancel with the 2 table. 2 fours are 2 5s are, which gives you minus 4 by 5. So this is one root and this is another root. Is that clear, children?
Yes, sir.
Fine.
Yes,
So
sir.
let us, yeah. So let us work out one more problem. 1 second. Screen has spent. One second, children.
Sir, any problem, sir? Jagdish garu.
Oh, no, sir, no, sir. Just screen stuck in it. Yes, sir, I'll continue again. Okay, children. Now let's move to the next question. Second question. See, children, if one root of the equation, I'll write the equation here, ix square minus 2 into 1 plus I into x plus 2 minus I equal to 0 is 2 minus I. This is one root. Then the other root is what? Okay. So here, better we go with alpha plus beta. Whenever one root is given and to find the another root, better we go with alpha plus beta or alpha into beta. Better. Like most of the cases, better we go with alpha plus beta. Okay, fine. So we know that alpha plus beta is minus b by a. Already we have discussed, we have solved it. Where alpha is one root, beta is another root. So alpha is how much? 2 minus I, which is given already. We don't know beta, means second root, we have to find. So plus beta equal to minus of b is x coefficient. What is the x coefficient, children? Minus 2 into 1 plus I divided by, and what is the x square coefficient, that is A, is I. Fine. So 2 minus I plus beta equal to minus into minus is plus 1 plus I by I. So better we multiply and divide by I. Okay, fine. So in order to avoid the confusion, multiply and divide by I. So see children, at a time I am multiplying 2 into 1 into I. 2I, 2 into I into I, 2I square. So I'll just write here by I square. Okay, so anyway, I square is minus 1. Again, we'll discuss clearly about it when we discuss about complex numbers. Fine. So 2 minus I plus beta equal to, so what will get? 2I minus 2 by minus 1. I square is minus 1, right? Fine. So take 2 common, children, or we'll take minus 2 common. Then what will get? 1. No, minus 2 common, right? So I, okay, one second. Screen is stuck. Okay, fine. Fine. So now, see, children, let us divide by minus 1 first. Don't take any common. I cannot erase it. Why? Because my eraser is not working. So divide by minus 1. So 2I by minus 1 is minus 2I. Please observe carefully. 2I by minus 1 is minus 2 by minus 2I. Minus 2 by minus 1 is plus 2. Clarity? Once again, 2I by minus 1 is minus 2I. Minus 2 by minus 1 is plus 2. We want to find beta, so transpose 2 minus I to right side. So minus 2I plus 2. So plus 2 will become minus 2. Minus I will become plus I. Children, are you following? Can someone please respond?
Yes, sir.
Okay. Yeah.
Yes,
Now
sir.
let us, yeah. Now let us simplify further. 2 minus 2 get cancelled. So finally we'll get minus 2I plus I. Minus 2I plus I is how much? Minus I. So which is our option A. If you want, I'll write option also in the bracket, which is our option A. Okay. So here, do not think about the solution. Whenever, if they are given one root and to find the another root, maybe suppose alpha is given and to find the beta. To find the beta. So remember, just go with alpha plus beta formula only. Do not go for substitution. It will take more time in this case of questions. So better go with alpha plus beta, which is minus b by a, where you already know alpha value. Simplify it so that you can get beta value. That is our second rule. Okay, children, is that clear? Okay, fine. Now let's move to the next problem. One more problem, third one. Please observe carefully. I'll write the quadratic equation first. 2x square plus k minus 3 into x plus 3k minus 5 equal to 0. Here they are saying that sum and product of the roots are equal. We are saying that sum and product of the roots are equal. So sum is nothing but alpha plus beta and product is nothing but alpha into beta. They are equal. Sum of the roots and product of the roots are equal. So sum, what is the sum formula? Can someone tell me? What is the sum of the roots formula?
B by A.
Minus b by a. Very good. And what is the product of the roots formula?
C by A. C by A.
C by a. Okay. So they have given sum of the roots equal to product of the roots. Sum of the roots formula minus b by a. Product of the roots c by a. A get cancelled. So finally we'll get minus b equal to c. So whenever you solve some MCQ questions or complicated basic questions, do not substitute the values directly. First simplify till what extent you can, like this. Then substitute. So minus, what is the b value? X coefficient, which is k minus 3. What is the c value, which is constant? 3k minus 5. And simplify, we'll get k value. So now multiply with minus, minus into k, minus into minus 3 plus 3 equal to 3k minus 5. Arrange all k terms at one side, constants at one side. So minus k and transpose 3k left side, minus 3k equal to minus 5, and transpose 3 to right side becomes minus 5, minus 3. Okay, so what we did, arrange all the k terms at one side, constants at one side. So minus 4k equal to minus 8, minus 8, minus get cancelled. So k equal to obviously 8 by 4, which is 2. Okay, so therefore k equal to 2, and option is C. I'll write the option also in the bracket. Okay, so this is also one of the important model for AM1. So if you can try the other problems, try it. If not, we'll solve the other problems, the rest of the problems in the tomorrow's class. Okay, so now just for 1 minute, did you understand today's class or any concerns from your end? Yeah, children, just for 1 minute. If you have any concerns, anybody, just ask one by one and just clarify. If not, we will move to the next class. Maybe I think chemistry. Any concerns, children? Any
Sir,
doubts?
where do we have these questions?
I think you might have received the C batch material, Amma. C2 material. C batch C2 material. This is part 1, Amma. C2 part 1.
Okay, sir.
You might have received already in your school, from your school. Okay.
Thank you, Jagdish Garu.
Yeah, sir. Thank you, sir.
If
Thank
you
you.
have
Thank
any
you.
doubt, please raise the hand and ask the doubt. Otherwise, we will start the next class.
Okay. So thank you, sir. Thank you very
sir.
much, sir. Thank you, sir.
Thank you.
Thank
Thank
you,
you very
children.
much.
Yeah. Thank you, sir. Thank you.
Sudhir Garu.
Yes, sir. Good evening, sir.
Good evening, sir.
Yes, sir.
I think you are waiting.
Okay.
Okay. Continue, sir, please.
Yes, sir. Thank you. Very good evening, ma, all of you. So I hope in yesterday's class, every concept which I told you, you have followed and you understood. Do you have any queries in this, the fundamental areas which I have covered in the last class? Anyone? Like Joel, is there? Please respond, Joel. Or Anirudh? Are you there? Please respond, ma. Anirudh. Okay, any other? Any queries in this regard? Redox reactions completely, we have completed yesterday's class. So if you say, okay, I will move on to the next topic. But before that, I need to have a cross check, small cross check by using just 2 or 3 questions. After finishing these 2 or 3 questions, then I will move on to the next topic. Okay. So already we have discussed completely what is meant by a redox reaction and how we can define them, how to identify the respective agents in the redox process, like reducing agent and oxidizing agent, and which is undergoing oxidation and reduction. All these factors yesterday we have completed. Now I am showing you one question. Which of the following reactions does not represent a redox change? A redox change means redox reaction only we have to consider. Okay. So here I have given you 4 total equations. Among these 4 equations, which equation does not represent a redox reaction? Okay. Can anyone of you answer this question? Yesterday, I told you clearly how to identify or how to cross-check whether the reaction is redox or non-redox. Right now. So based on that awareness, please try to tell me the answer for this question. Equation 1, 2, 3, 4. 4 are there, which is not representing a redox process. Once you have a look and tell me, please. Anyone, please? Tejasri from Guntakal branch. Bharat Kumar. Please respond. Anyone? You can unmute and you can answer this question. So among these 4 given options, which is not a redox reaction? Okay. So here, whenever you want to identify the redox reaction or not, you need to cross-check the oxidation numbers of the elements. Okay. So yesterday also same thing we did. Okay. Na? So now in this first equation, if I say, okay, Esma, tell me, no problem. I think Shrestha.
Sir,
Yes.
first equation maybe.
Esma, first equation, right?
Sir.
Okay, very good. First equation is not a redox reaction. So on what basis we can say first equation is not a redox process is, yesterday we had discussed oxidation number concept. Okay, so oxidation numbers of the different elements in the overall chemical equation, first we have to analyze. So when we are analyzing, if any change in the oxidation number of elements in the overall process, we can confirm it as a redox process. And there is no change in the oxidation number of any element in the overall equation, then we have to say it as a non-redox process or non-redox reaction. So according to that principle, here initially before the reaction, calcium, I can say it is present in +2 form. Carbon is present in +4 form. Okay, carbon is present in +4. And here oxygen is present in -2 oxidation state. Or else directly if you want to say also, calcium is present in +2 form and a carbonate radical altogether. Okay, carbonate radical is present in -2 form, I can say. Like that also we can consider. But when you are going through an element specific oxidation numbers, there will not be any confusion to identify the change in the oxidation number of different elements. Okay, so as per this data, before the change, calcium is +2, carbon is +4, and oxygen is in -2 oxidation states. Now, after the reaction, once you have a look. So what is the oxidation number of calcium? Even in this calcium oxide also, I can say oxidation number of calcium is +2 only. And as usual, oxidation number of oxygen is also same, -2 only, I can say. So that is the condition we can observe in the calcium oxide. And when it comes to carbon dioxide, carbon is again, it is present in +4 oxidation state, and oxygen is it is as usual present in -2 oxidation state. Now, after identifying their oxidation numbers or oxidation states, we have to compare their oxidation numbers before the change and after the change. So can you find any change in the oxidation number of any element in this overall equation? Tell me please. Calcium +2 and after reaction also +2. Carbon is +4, after reaction also +4. And oxygen is -2 before the change and even after the change. Right now? So as there is no change in the oxidation numbers in this equation, I can say this is not a redox reaction. This is not a redox reaction, I can say. But if you see the other equations, like second, third, and fourth equations, when you say, definitely you can observe some change in the oxidation numbers of the different elements. Here, in the second equation, hydrogen is present in the 0 oxidation state, and oxygen is also present in the 0 oxidation state. But after the formation of water, that is product, hydrogen is converted into +1 oxidation state, and oxygen is converted to or enters into -2 oxidation state. As per the crisscross formula I am talking about. In 9th standard regular board syllabus also already we have learnt about atoms and molecules. No? So there we have already how to write the chemical formula as per the valencies of the radicals and as per the steps involved in the crisscross method. Okay. So now this hydrogen becomes +1. So 0 to +1, it is increase in the oxidation number. So I can say hydrogen is undergoing oxidation process. Am I right or not? Likewise, oxygen, if I consider, it is going to 0 to -2. So 0 to -2, I can consider it as decrease in the oxidation number. Okay, no? Decrease in the oxidation number. So oxygen is undergoing reduction process, I can say. That means here both the elements, there is some change in the oxidation number, so that I can confirm this reaction as a redox reaction. So likewise, third equation and fourth equation also, we can easily analyze and we can confirm since there is some change in the oxidation numbers of the elements, easily we can say equation 2, 3 and 4 are belongs to redox type of reactions, and equation 1, as there is no change in the oxidation number of any elements, I can say it is a non-redox process. Okay, so likewise, another example I am telling you. So second question is also very similar model. Every element oxidation numbers we have to once cross check. In which reaction there will be some change in the oxidation state of the elements, we can say that is nothing but redox reaction. Okay, so in this case also, if I consider and if I want to reveal the answer, I can provide you the correct answer is option 4. That is the reaction between zinc and HCl to form zinc chloride and hydrogen gas. I can say it is involved in the redox reactions or redox process. Why? Because zinc is displacing hydrogen from the hydrochloric acid. So that what happened? Zinc chloride is formed along with the liberation of H2. So when you compare the oxidation state, zinc initially it is 0, but in the zinc chloride, zinc is present in the +2 oxidation form. Right now, so zinc is losing 2 electrons in this process and it is converted into +2 oxidation form. Okay, so 0 to +2, there is an increase in the oxidation number. Hence, zinc is undergoing oxidation. And hydrogen point of view, if I consider hydrogen in the hydrogen chloride or hydrochloric acid, it is present in +1 oxidation state. Right or not? It is present in +1 oxidation state. These two H+ ions in the hydrochloric acid will be accepting 2 electrons lost by the zinc, so that the 2 H+ ions are discharged or liberated in the form of neutral hydrogen gas. Okay, so here what I can say, before the reaction, hydrogen is present in +1 oxidation number, but after the reaction, hydrogen is converted into 0 oxidation state, elemental form. So +1 to 0, there is a decrease in the oxidation number. So I can confirm in this reaction, hydrogen is undergoing reduction process. So zinc is undergoing oxidation and hydrogen is undergoing reduction process. So that's why I can confirm this reaction as a redox reaction. Okay, now, so just for model, I'm presenting these 3 questions. Please make a note of it. So whenever they're asking to identify among the following equations, which belongs to redox reaction or which belongs to non-redox reaction, means only the thing what you have to analyze in the equation is you have to observe and you have to identify the oxidation numbers of the elements present in the overall equation. After observing oxidation numbers of all the elements before the change and after the change, if any change in the oxidation number of any element, you have to confirm it as a redox reaction. If there is no change in the oxidation number, we have to confirm it as non-redox reaction. Okay, na? So like that, based on the redox reactions and all, these 3 questions just I would like to discuss with you. And I wanted to give you clarity on the process, how we have to identify the redox reaction and non-redox reaction. Okay, so I hope it is clear in the redox reactions and all. Now, the next topic which we have to focus in this electrochemistry is, as we are discussing about totally electricity and chemical reactions or conduction of electricity by different substances. So how these different chemical substances in the nature are able to conduct the electricity. Okay, how these chemical substances are able to conduct the electricity. That means we must understand how many types of substances we can have based on the conduction property. Okay, how many substances we can have, and that means a kind of classification based on the conduction property of the substances. Okay, so based on this conduction property, overall you are seeing on the slide on the screen, there are 4 different types of substances we can observe in the nature. Okay, the very first one is superconductors, and the second one is conductors, third one is semiconductors, and the fourth last one is insulators. Okay, so here before discussing about the types of conductors and all, means metallic and electrolytic conductors, you need to understand based on conduction property how many types of substances we can observe in the nature. Okay, superconductors, conductors, semiconductors, and insulators are the 4 different categories generally we can have in the nature. Okay, so one after one, we need to understand what does it mean. A superconductor means what, or a conductor means what, like that. Okay, so first I'm choosing superconductors. Okay, so superconductors, if you see here, the substances which have zero resistivity and infinite amount of conduction property. Okay, the substance which have zero resistivity and infinite amount of conduction property, those are called as superconductors. That means to the maximum extent, conduction property is shown by such a kind of materials. Okay, so those materials generally we can consider as superconductors. Conduction property is a very high or maximum extent we can see in those kind of substances. So, okay, now, so for this best examples, I can say alloys at lower temperatures. Okay, alloys at lower temperatures generally we can consider as superconductors. So here, alloys means we know. What is meant by an alloy? Can you tell me? What is meant by an alloy? Please. Do you have idea on alloys? You have to respond.
Sir,
Yes. Yes, ma, Soumya, please tell me. Alloy means what? Or else Resta. You can unmute and you can answer, ma. No problem.
Compost of
The
one
metal
or
made
more of
combining one or two metals.
Okay, very good. So simply if you want to say alloys means the mixture of a homogeneous mixture of 2 or more metals or metal with non-metal. Okay, na? So we are mixing together either 2 or more different metallic elements we are mixing together in the molten state to form an alloy, or metal with non-metal also sometimes we may mix in order to get the alloys. So all these alloys generally at lower temperatures they can act as a superconductors. That is 0 to 15 Kelvin temperature. Generally, we can expect the superconduction property for the different alloys. And not only this, ceramic, when it is mixed with some oxides of metals also, at 150 Kelvin temperature, they can also show the superconduction property. And very soon you are going to learn in your 10th standard board syllabus also, carbon and its compounds. So there in the carbon and its compounds also, we have one important allotrope of the carbon, that is fullerene, Buckminster fullerene. It is like a football. Okay, so that Buckminster fullerene also a very good example for the superconduction property of the substances. Okay, so like that, different substances we can take as an example for superconduction. But here, what mainly you have to remember, superconductor means the superconductor will be having zero resistance and infinite conduction property. Okay, zero resistance or resistivity and infinite conduction property or conductivity is exhibited by such kind of substances. Okay, that is called as superconductor. And next, if I take second one, conductors, I can say. So conductors means generally simple, in a simple statement, I can say the substances which allows the passage of electric current. Okay, now here, as we are discussing about electrochemistry, we are choosing electrical passage, electrical current passage. But in general, thermal conductivity also we have. Generally, metals are good conductors of electricity as well as heat. Okay, so metals generally can show thermal conduction property as well as electrical conduction property. Okay, but here, as we are discussing about only electrochemistry, just I am focusing on the electrical conduction property of the different substances. Okay, so conductors means which allows the passage of electric current through them. Those type of substances generally called as conductors, I can say. So best examples for the conductors, please make a note of these examples. Later, I will ask you one question regarding these two examples, two types of examples. Okay, so generally, now what are the examples here I have listed out? Some metals I have given you. Up to first three, if I consider silver, copper, and aluminum, these are all metals. And some aqueous solutions also I have provided as an example for conductors. Okay, na? So either in the elemental form or else in the compound form, some substances, they allows the passage of electric current through them. Those are generally considered as conductors in the nature. Okay. So superconductors means infinite conduction is there, and conductors means they'll allow the passage of electricity through them. Those are called as conductors. With the examples we have to remember. Next, the third one, if you take, it is well known for us, semiconductors. Okay. So where we are using these semiconductors, can you tell me where we are using?
For metalloids.
Semiconductors are generally, yes ma?
Metalloids.
Metalloids only. Generally, semiconductors are metalloids, but in the general electrical circuits and all, we are using these semiconductors especially. Okay. So here, how can you describe the semiconductor? Very carefully, you need to understand this. Semi means it is partial. Okay. It is not acting as an insulator or not acting as a fully conductor. Okay. Partial conduction property is exhibited by these type of materials or substances. That's why we are calling them as semiconductors. But if you compare their nature, when they are taken in the pure form, okay, when they are taken in the pure form or in their natural existence, generally these type of substances acts as bad conductors or poor conductors of electricity. Okay, when I take any substance, any semiconductor in the pure state or in the natural state, they are acting as very poor conductors or bad conductors of electricity. Okay. So poor conductor or bad conductor means a very minute conduction property we can see. That's what exactly meant by poor conductor. But the first two lines you see here, these substances shows the conduction property. Okay. These substances shows the conduction property between the conductors as well as insulators, which already I said. At the same time, we are telling these are actually poor conductors in the natural state, but the important condition which we need to understand here is whenever we are mixing these substances with any other impurities or any other elements, these substances can increase their conduction property so that they are acting as semiconductors. Okay, now, so in the pure form, they are actually poor conductors or bad conductors. But whenever we are mixing with some other chemical substances, they increases their conduction property. Hence, they are acting as semiconductors. We need to understand. Okay, na? So for such kind of semiconductors, best examples I can say the different metalloids we can consider. Among metalloids also, silicon is very well known to us. Why? Because the silicon and germanium, these two metalloids generally are used in the electrical circuits as a semiconductors. Okay, in different transistors or radios. Okay, such kind of electrical gadgets in the circuits, they are going to use these metalloids as a semiconductors by mixing with some other kind of substances. Okay, so that is what mainly you need to understand what exactly meant by a semiconductor. So 3 points I said. Semiconductors means they'll exhibit the conduction property between the conductors and insulators. That is point number 1. Point number 2, originally means in their natural state, they are actually bad conductors. But point number 3, whenever we are mixing with some other elements or impurities, they'll increase their conduction property and they are acting as semiconductors. These 3 points you have to understand very carefully under this semiconductors, and examples anyhow you can list out. Okay, so these 3 over. And the last one is very simple to understand, and you know very well this. Insulators. What is meant by an insulator? Generally, when you observe the electrical wires, okay, either copper wires or aluminum wires in our household usages, that electrical wire, metallic wire is coated with some PVC material, right? No, some rubber or plastic material is coated on the bunch of electrical wires, right? No. So why we are giving that plastic coating or rubber coating on the electrical wires? Because these type of materials does not allow any passage of electric current through them. Okay, these type of materials, they does not allow the passage of electric current through them. That's why as they does not allow the electric current through them, if we give a coating of these type of materials, we won't get shock even though we are just touching those electrical wires from the external surface. Okay, so like that. So insulators means they does not allow, okay, they does not allow the electric current through them. Such kind of materials generally can be treated as insulators. Best examples for the insulators are rubber, plastic or glass, ceramic, all these type of substances, we can consider them as insulators. Okay, so here in this chapter, the next point which you need to remember is classification of substances. Okay, classification of substances based on the conduction property I said. So totally 4 substances we have seen. One is superconductor, second one is conductor, third one is semiconductor, and the fourth one is insulator. Do you have any queries or any doubts in this regard? The classification of substances into 4 different types. Okay.
Sir,
Yes, ma'am.
you explained a question before this, no, sir? Redox reaction.
Yes, ma'am.
Sir, can we take boron as semiconductor?
Yes, ma'am. Boron is also a metallite, so we can consider. Okay. Yes, Shrestha, something you're asking regarding redox reaction.
Can you explain again that Zn and HCl question?
Zn plus HCl, ma? Okay, just give me 2 minutes. I will conclude this part. I will go back. Okay, na? No problem.
Sure.
Again, this point you will be confused. Okay. So anyone, if you have any concerns regarding these superconductors, conductors, and semiconductors or insulators, you can ask me the question now. Okay. If you don't have any queries, I have a question. I will ask. Okay. Shall I ask?
Yes, sir.
Yes, sir.
Anyhow, I will explain. Okay. But you try to answer. Try to guess and answer. So here, when I'm telling you superconductors, I said they are showing infinite conductivity and zero resistivity. That is fine. As per the physics also, we can understand simply. Why? Because conductivity is inversely proportional to resistivity. Whenever resistivity increases, conductivity decreases, or resistivity decreases, conductivity is increases. Inversely proportional. That is very clear. But here, one condition I said when I'm discussing about superconduction property. Okay, what is that condition? Generally, these materials, whichever are acting as superconductors, they are acting as superconductors at lower temperatures. Okay, at normal room temperature, if you take, they cannot show or exhibit their superconduction property. Okay, generally at lower temperatures only, these substances will show superconduction property. Now, can you guess what is the reason behind why these are always showing superconduction property when they are maintained at lower temperatures? Please, if you have any guess, no problem. Whether it is correct or incorrect, it is secondary. You have to try it. Okay.
Sir, can you repeat the question?
My question is, we are telling some substances will show superconduction property. Okay, high conduction property they are exhibiting. But superconduction property is generally exhibited by the material at low temperatures only, not at high temperatures or at normal temperatures. Okay, at lower temperatures only superconduction property is observed. What is the reason behind that lower temperature?
Sir,
Yes, ma'am.
if higher means they are in gaseous state. If higher means they are in gaseous state, sir.
Higher means they are in gaseous state. Huh? Okay, at normal room temperature, if I take, they are solids only, no, all metals except mercury. Right now? Okay.
Sir, at higher temperature, molecular vibration will increase, sir. That will increase resistivity.
At higher temperatures?
Molecular vibrations will increase, sir.
Yes, absolutely right. Very good, ma. Okay. So, at higher temperatures, molecular vibrations will be increased. Okay. So, remaining all, please write down this question. I will show you a small animated video in the next slides and all. Then I will give you clarity on this particular. But you remember this question. My question is, why superconduction property is exhibited at lower temperatures only. Okay, na? This is one question I need to give you clarity regarding this different types of substances. Am I clear? The reason is absolutely right, ma. So just I will little expand and I will give you clarity and I will visualize that how it happens. Okay, so now in this question, I said zinc with HCl is a redox reaction, I said. Okay, so I hope Shrestha you're following. Okay, so zinc initially, oxidation number of zinc is 0. Yes, ma? Before the reaction, when nothing is there, no charge is represented on the element means it is 0. Okay. And in the compound form, hydrogen and chlorine, if I analyze, hydrogen is present in +1 form and chlorine is present in -1 form. Right or not? Okay. So hydrogen is in +1 form and chlorine is present in -1 form. Now, zinc after the reaction, if I compare, zinc is entered or present in +2 oxidation state and chlorine as usual it is -1. But hydrogen, its oxidation number changed to 0. Why? Because it is liberated in the neutral elemental form. Okay. Now you compare oxidation number of zinc. It is 0 to +2. That means increase or decrease in the oxidation number? It is increase in the oxidation number. That means, can I say zinc is involved in the oxidation process? Okay. Yes. Zinc is involved in the oxidation process. That means it is oxidation. And hydrogen point of view, if I consider, initially before the reaction, it is +1. But after the reaction, what is oxidation state of hydrogen? It is 0. That means +1 to 0. Decrease in the oxidation number, I can say. Right or not? Okay, na? It is decrease in the oxidation number. So hydrogen is involved in the reduction process. So in this overall reaction, one element is involved in the oxidation, that is zinc, and other element is involved in the reduction, that is hydrogen. So both oxidation and reductions are taking place in this reaction, so that I can say it is a redox reaction. Okay, na?
Okay, sure. Thanks.
Like that, we need to understand. So above 3 reactions, if you observe, there will not be any change in the oxidation number of any element. Afterwards, leisurely, you can cross-check oxidation numbers, no problem. So there will not be any change in the oxidation number of any element. That's why remaining 3 options, we are not choosing as redox reaction. Okay, na? That's what.
How
Yes,
did you say the zinc oxidation number?
Zinc oxidation number is?
How can you say, sir, the zinc oxidation number?
How can we say means general oxidation numbers we have to remember, ma. In the lower classes, we have list of ions, no? Like sodium ion means Na+1, magnesium means Mg +2. Okay, nitrate means NO3 -1, like that. That list of ions generally we have to remember. And moreover, if sometimes if any new elements or new compounds are appeared also, based on crisscross method, we can easily identify the oxidation state in general. Okay, to some extent that is possible in the basic level of the contents. Okay, compounds. So for example, I hope you know about crisscross method, how to write chemical formula.
Yes, sir.
Yes, no. So first we need to take the symbols of the ions we know. Okay, so here zinc and chlorine are present. So for these elements, their general valency numbers we have to write. So zinc is generally exhibits valency 2 and chlorine exhibits valency 1. So as per the crisscross method, if I interchange, okay, as per the crisscross method, 1 will come for zinc and 2 will go for chlorine. That's why zinc chloride chemical formula, we are representing it as ZnCl2. Even though 1 we are writing it or not, there is no problem. That's why ZnCl2 is a chemical formula of the zinc chloride at Z. So now, after identifying the valency numbers from the crisscross method, okay, that means here from this formula itself, I can say this 2 belongs to zinc. That means valency of zinc is 2, and here 1 is there, chlorine valency is 1. After identifying valency numbers, we have to identify the nature of the element. Yesterday also I told you electropositive element and electronegative element, right? No? So always we need to understand here one thing. The electropositive element will be showing positive oxidation number and electronegative element will be showing negative oxidation number. Okay. So here valency number is associated with either positive sign or negative sign, that is called as oxidation number. Okay. Valency number associated with either positive or negative sign is called as oxidation number. So from the crisscross method, already you know what is the valency numbers of zinc and chlorine. That is step 1 you have to understand. And step 2, you have to describe or identify their nature. Okay, generally I can say zinc is electropositive in nature. Why? Because metals are electropositive in nature. Because always they are having tendency to lose the electrons. Okay, so zinc is electropositive, so that to this valency number of zinc, I can place +2. Okay, na? Valency number is 2. And since it is electropositive, I need to attach it with the positive sign. So that means zinc initially 0 and it turns to +2 form. Okay. So likewise, we can easily identify the oxidation numbers of the elements. Okay. So in the basic or fundamental compounds, we can go with this. And in the complex compounds, if you want to find, there are 2 important rules we must remember. If possible, please write down the rules. Okay. Rule number 1, I am telling you. Rule number 1, the sum of oxidation numbers of all the elements. Okay. The sum of oxidation numbers of all the elements in a neutral molecule is equal to 0. That is rule number 1 you have to understand. Okay, na? Sum of oxidation numbers of all the elements in a neutral molecule is 0. That is rule number 1. And rule number 2, regarding ions, you have to describe. Okay, same statement you can say, but instead of a neutral molecule, we have to consider ion. Okay, so how I can change rule number 2 is the sum of oxidation numbers of all the elements in an ion is equal to its charge present. Okay, na? The sum of oxidation numbers of all the elements present in an ion is always equal to the charge present on the ion. Either positive ion means it is equal to positive charge. Negative ion means it is equal to negative charge. Okay, na? Did you understand these 2 rules?
Sir, once please repeat second.
Second statement, the sum of oxidation numbers of all the elements in an ion, the sum of oxidation numbers of all the elements in an ion is equal to charge present on the ion. Is equal to charge present on the ion. Okay, na?
Yes, sir.
Yes. So in this regard also, general oxidation numbers of different elements, you must remember that knowledge is very important wherever you go. Okay. General oxidation numbers. So now, for example, I'm taking this example, BrO3 minus. Okay, na? BrO3 minus. So in this ion, I want to find out the oxidation number of bromine. Okay. So whenever for any element you want to find the oxidation number, imagine that element oxidation number as X, because we don't know that. Okay. X plus, and the remaining all elements general oxidation numbers you must consider. What is the general oxidation state of oxygen in general? How oxygen is available in the ionic form? It is in O-2 form, right? -2 only, no? General oxidation state of oxygen is -2. Okay.
Yes.
So now, like that, how many oxygen atoms are present in this ion? 3 oxygen atoms are present. So I have to take the total product. 3 oxygens are present. Each oxygen is bearing -2 oxidation number. Okay. So any other elements are involved in this ion? No. That means sum of all the oxidation numbers of elements is equal to charge present on the ion, I said, second statement. This is a negative ion. What is the charge present on the negative ion? It is -1. So I will make it equal to -1. Okay. Now, can you find out X from this one? X minus 6 is equal to -1. So 3 into -2 means -6 only, no? So X minus 6 is equal to -1. And obviously, X is equal to how much? If you bring this -6 other side, it becomes +6. So +6 minus 1. So the oxidation number of bromine in this ion is +5. Okay, na? Clear, ma? So like
Yes,
that,
sir.
yeah, like that, we can easily find out the oxidation numbers based on the formula method, or else directly from the crisscross method also, we can find it. Okay, I hope this is clear. Now, in today's topic, we have already completed. There are 4 different types of materials: superconductors, conductors, semiconductors, and insulators. And the reason for superconductors, I will explain. Okay, so now here, if I consider mainly in the electrochemistry, we won't bother about superconductors or semiconductors or insulators in general. Our total study in the electrochemistry is mainly related to the conductors. Okay, it is mainly related to the conductors. So here also I told you some examples I have given in the elemental form, and some examples I have given in the compound form, that is in the aqueous solution form. Okay, so all these different forms of the substances which can allow the passage of electricity are generally considered as conductors. Okay, now we are going to study in detail about only conductors. How many types of conductors are present, and what are those, and how or which kind of different factors are affecting the conduction property of these substances. First, we need to understand in a detailed form. Okay, so now here, if you observe, there are 2 different types of conductors we can see. Don't get confused. This is substances classification based on conductivity. Okay, and now we are exclusively going to study on conductors, how we can classify the conductors. Okay, so here the requirement to classify the conductors into 2 different types is based on their availability in the nature. Okay, based on their availability in the nature. Already we know that we can see the existence of different chemical substances in the element form and in the compound form. Right or not? Element form and compound form is present. Can you tell me what is the difference between element and compound? Yes. What is the difference between element and compound? Please.
In compound,
Yes, yes.
sir, in compound, the molecules are combined in fixed ratios, whereas in elements, there is no fixed ratios.
Okay, little I can accept, but not so exact statement what you have given. Any other?
Elements cannot,
Yes, ma'am.
elements cannot be broken into simple forms, sir.
Okay, very good.
Compounds are the combination of elements in fixed ratio.
Very good. Okay, I'll accept this statement. Okay, so elements cannot be furtherly divided into any other new or simpler substances by means of either physical or chemical methods. Okay, that means what I can say here, elements are generally made from same kind of atoms. Can I say like that? Elements are generally made from same kind of atoms. Okay, and when it comes to compounds, these are combination of different atoms or elements. For example, when sodium is combining with sodium chlorine, it forms NaCl, sodium chloride. And sodium alone, if I take here, that is element form of sodium, or else chlorine alone, if I take, that is elemental form of chlorine. So when these 2 elements are combined together in a fixed ratio by mass, that resultant new species which is produced with entirely different properties are generally called as compounds. Okay, so here I'm using one important term, that is entirely different properties. Okay, so comparing between the constituent elements involved in the compound formation, the resultant compound or product is having entirely different properties. I will say here itself, I can say sodium is really a poisonous element. It is poisonous in nature. Chlorine is also poisonous gas, right or not? Okay, now sodium is a poisonous element, and chlorine is also poisonous gas. That is the reason we are using chlorine in the purification of drinking water to kill all the bacteria and germs present in the water. It has some poisonous effect. Okay, It kills all the germs and bacteria present in the drinking water. That's why chlorination treatment is given finally for the drinking water. Okay. So these two elements which are poisonous in nature, when these two are combining, the chemical substance or compound which we are obtaining is sodium chloride. But that sodium chloride we are frequently using for the consumption process. Right or not? In every food material without salt, generally we won't like it. Right now, it enhances the taste of the food. So by combining two different poisonous materials, one important and useful chemical substance we can produce in the nature. That is a specialty of chemistry. Okay. So between the element and compound, if you consider, element is made from only one kind of atoms and it cannot be furtherly broken down. But compound is made from different kind of atoms or elements which are combined together in a fixed ratio by mass. Okay. That is what main difference you need to understand. Okay. So here why I'm asking this difference, element and compound difference, is when it comes to the classification of conductors, main reason on what basis we can classify them into two important types is based on this existence in the nature. Some materials or some conductors are present in the elemental form and they allows the passage of electricity, and some substances are present in the compound form and they are allowing the passage of electricity. Based on this difference, we are having mainly two important types of conductors in the nature. Okay, what are those two important types of conductors is, one is metallic or electronic conductors. Okay, I hope you're writing the main terms and all. Okay, now, so the first type of conductor which you have learned in detail is metallic or electronic conductors. And the second type is, I can say here, the second type of conductor is ionic or electrolytic conductors. Okay, na? Ionic or electrolytic conductors. These are the main two important types of conductors we are going to discuss now. Okay, na? So now here if I consider, first in detail, I will discuss about the metallic or electronic conductors initially today. Okay, so now in this regard, if I consider what happens, a metallic or electronic, the name itself is indicating the required condition in order to conduct the electricity by these type of substances is only the presence of free electrons. Okay, now only the presence of free electrons. Due to the presence of free electrons, those electrons will be flowing from one to another kernels or atoms, so that flow of electron is nothing but electricity we are taking. Okay, so like that, flow of electrons is involved in this type of conductors, and that flow of electron is possible due to free electrons present in the elemental form. Okay, so now here I say metallic conductors or electronic conductors are generally exhibits or shows the conduction property due to the presence of free electrons. Okay, due to the presence of free electrons. And this is possible especially in the metallic elements. That's why these conductors are named as metallic conductors or electronic conductors. It is shown by metallic elements. That's why we are calling it as metallic conductors. And due to flow of electrons only, the conduction property is seen. That's why it is also called as electronic conductors. Okay. So electronic or metallic conductors we can see. So generally these type of conductors will follow Ohm's law. Okay, now these type of conductors are generally following Ohm's law we can consider. So Ohm's law and all in tomorrow's class I will explain. But how and what happens during this metallic conduction, I wanted to give you some idea in detail. Then I will conclude today's class. Okay. Once you have a look on this animated video, I hope you can see the screen clearly. The video is playing, right?
Yes.
Yes. Okay. So generally, here once you see, this is a metallic rod, you say. Just either it may be aluminum or copper or a silver, whatever. Metallic rod when I am taking. This metallic rod is overall, it is made from the respective metallic element. All metal atoms are present in the sample. Okay. So now, how this conduction property is possible due to the flow of electrons, we need to understand here. So exactly in depth, if you analyze this metallic arrangement, all the atoms are arranged in this different fixed positions and all. Okay. And we know that metals are having electropositive character, right or not? Metals are having electropositive character. That means the valence electrons are loosely held by the nucleus in the metallic elements. That's why these electrons can be easily coming out from the metals, so that metal positive ion and the free electrons can be adjusted like this. This type of arrangement is called as electron C model. Generally, when we are learning about metallic bond, this electronic C model we used to discuss. Okay. So in the metallic bond arrangement, if you see, positively charged metal ions are fixed in the positions, in the lattice positions. And from the valence shell of these metals, the electrons will be moving freely from one atom to the other atom. How it happens once you have a glance. Okay, so this is actual arrangement. Initially, the electrons are loosely held by the nucleus. I hope the video is playing and you can see the movement of electrons. Okay, so like this, the free electrons will continuously flow from one metal ion to other metal ion, and like that it continues in the throughout electrical wire. So see, like this, the flow of electrons is observed in the metallic or electronic conductors. That is the reason why the metallic or electronic conductors are conducting the electricity due to the flow of electrons, or due to the presence of free electrons. Okay. Imagine if these free electrons are not present, then what happens? Automatically, the electronic conduction is not possible. Okay, now the electronic conduction is not possible. So now, before I asked you one question, why superconduction property is possible only at lower temperatures? For that, I think from Hospet branch, he has answered like vibrational moment of the atoms will be increased at higher temperatures. Okay, so we know that temperature increases means kinetic energy of the particles in the matter increases. So generally at higher temperature, what happens, you know, the kinetic energy of these metal ions also will be increased, and they also will start moving along with the free electrons. Once you observe carefully this 30 seconds, just see here. Initially, there is no movement of these atoms. Okay, now, but at higher temperatures, if I bring that metallic sample, along with the electrons, even these metal ions also will start moving because of increased kinetic energy. So when these vibrations of atoms are increased, what happens, ma? They will definitely obstruct the flow of electrons. Okay. So flow of electron is not in a proper way means automatically the conduction property also will be decreased. Okay. So in the normal condition, the metal ions are in the fixed position, only electrons are flowing. At that time, conduction property is very good. Okay. But at higher temperatures, if I bring this metallic sample, along with the electrons, even the kernels, positive ions also are moving continuously. That's why here, because of this vibrational moment, increased vibrational moment, I can say the flow of electrons will be obstructed. So the conduction property is decreased. Okay. Now you can get get the answer for my question. Before I asked you, why at lower temperatures only these will exhibit superconduction? Can you guess and tell me now? Why? Because at lower temperatures, what about kinetic energy of these particles in the matter or atoms of metal? Very less, right? No, at lower temperatures, kinetic energy of atoms is very less. So more strongly, the positions of these kernels will be fixed up. So only flow of electrons is very easy, so that the conduction property will be increases at lower temperatures. Okay, na? Did you get my point? Yes. Okay. So for today, I wanted to stop here in these main areas of the topic. If you have any doubts and all, you can ask me. Otherwise, we can wind up the session. Mainly, we are discussing about 4 types of substances in today's class. And after 4 types of substances, metallic conductors we are discussing. Okay. So why metallic conductors requires free electrons? I told you the reason. And how it is possible, conduction property. I have shown you the video and the total arrangement of sample and all. In tomorrow's class, I will explain how and what kind of factors can affect the metallic or electronic conductors. Then I will ask you some important questions for the model. Okay, na? That's it. So if you have any queries, you can ask me. Otherwise, we can close the session.
Thank you, sir. Thank you, Sudhir garu.
Yes, sir. Thank you, sir. Thank you very much, sir.
If you have any doubts, please raise the hand and ask the doubt. Otherwise, we will conclude the class. Thank you very much. Good night, sir.
Thank you,
Good night
sir.
to all.